On the morning of June 30, 1908, an object exploded in the sky above central Siberia. The blast released the energy of 1,000 Hiroshima bombs. It flattened a forest the size of metropolitan Tokyo. It registered on barometers in Washington, D.C. It made the night skies over Europe bright enough to read newspapers outdoors. No crater was ever found. No fragment of the object was ever recovered. Origin Protocol. Classified Record 3. Subject Designation, Human, D-CR003. Classification, Historical Event of Undetermined Origin. File Status, Closed without resolution. Sergei Semenov. Was a fur trader at the Vanavara station, 65 kilometers south of the detonation point. He told Soviet investigators, decades later, that he was thrown from his porch chair, that his shirt felt as though it were burning, and that he saw the sky split into two above the northern horizon. Indigenous Evenki families closer to the blast described their reindeer killed in herds, their summer huts incinerated, and the forest standing as a wall of fire. At the Irkutsk Magnetic and Meteorological Observatory, 900 kilometers away, instruments registered a strong atmospheric pressure wave at 17 minutes past 7. Within hours, the wave had crossed Eurasia. Barographs in Britain recorded it. Seismographs across Europe registered the impact. Between June 30 and July 2, the night skies from London to Berlin remained bright enough to photograph in. Newspapers reported people reading on park benches at midnight. Whatever had happened in Siberia was visible across the world. The Russian government did not investigate. 1927. Soviet mineralogist Leonid Kulik becomes the first scientist to reach the blast center, 19 years after the event. He expects to find a crater. He expects to find iron meteorite fragments. He finds neither. What he finds is a forest flattened in a radial pattern across more than 2,000 square kilometers, with the trees pointing outward from a single epicenter. At that epicenter, a small group of trees remained standing, stripped of branches, scorched on top, but vertical. Kulik publishes the first interpretation. The object did not strike the ground. It detonated in the atmosphere, above the forest, in a phenomenon now called an airburst. The modern consensus, refined across the 20th century by NASA and the International Astronomical Union, holds that the object was a stony asteroid approximately 60 to 200 meters in diameter, which exploded at an altitude between 5 and 10 kilometers due to atmospheric pressure. This explanation accounts for the crater's absence and for the radial blast pattern. It does not account for the absence of meteorite fragments. After a century of searching, almost no confirmed material from the object has ever been recovered. 1934. American astronomer Fred Whipple at Harvard Observatory proposes a different object. An asteroid is dense rock or metal. When such an object disintegrates in the atmosphere, it should leave fragments. The Tunguska object did not. Whipple's hypothesis is that the object was the fragment of a small comet, a body composed primarily of ice, dust, and frozen gases. Such a body would vaporize on entry. It would leave no metallic fragments. And it would release vast quantities of fine dust into the upper atmosphere. This last detail is what the comet hypothesis explains particularly well. The bright nights across Europe, the silvery noctilucent clouds documented by observatories from London to Berlin, matched the signature of high-altitude ice and dust-scattering sunlight. Soviet astronomer Vasily Fisenkov, working independently, reaches similar conclusions in 1961. The cometary hypothesis dominates 20th century thinking. It has been challenged in the 21st. Recent simulations of atmospheric entry by NASA's Sandia laboratories suggest a stony asteroid better matches the energy distribution. Two well-supported hypotheses. Two different objects. The same crater. Which is to say, the same absence of one. 2007. A team of Italian scientists from the University of Bologna, led by physicist Luca Gasparini, publish a different claim. They have been studying Lake Checo, a small body of water approximately 8 kilometers from the blast epicenter. The lake is roughly oval. It is approximately 50 meters deep at one end. The Bologna team argue that its shape, its bathymetry, and the layered sediment at its bottom are all consistent with a small fragment of the Tunguska object having survived the airburst and struck the ground at high velocity. If correct, Lake Checo would be the first physical evidence of the object itself, not its blast. The proposal was significant. It was also rapidly contested. Subsequent investigations by Russian geologists, including Rogozin and colleagues in 2017, examined sediment cores from the lake bed. They concluded that the lake's lowest layers predated 1908 by at least several hundred years, and possibly several thousand. The lake, in their reading, was already there. The question is unresolved. The Bologna team maintains the impact interpretation. The opposing teams maintain the prior existence finding. 3 centuries of geological data remain in dispute over a single lake. 3 hypotheses. 3 frameworks. None confirmed. None refuted. What remains, after a century of scientific investigation, is what did not happen. There is no crater. The expected impact crater of a 60-meter asteroid was never found. There are no fragments. Despite multiple Soviet expeditions in the 1950s and 60s, despite microscopic searches for silicate and magnetite spheres, the recovered material is too small and too ambiguous to confirm composition. There is no consensus on object type. The asteroid model and the cometary model both account for some observations and not others. There is no consensus on Lake Checo. What there is a forest that was flattened across 2,150 square kilometers in a single morning, barometers in Washington that recorded the wave, observatories in London that recorded a sky brighter than any moon, and indigenous testimony of fire in the air. The event left a footprint. It erased its cause, set Tunguska next to its successors. On February 15, 2013, an asteroid approximately 20 meters in diameter exploded above Chelyabinsk in the southern Urals. The blast yield was approximately 500 kilotons, roughly 30 times the Hiroshima bomb, but only 1/20th of Tunguska. It injured nearly 1,500 people from the shockwave alone. Astronomers had not detected it before impact. 1947, the Sikhotalin meteor in eastern Russia. 1963, an airburst over the South Atlantic detected by U.S. nuclear monitoring satellites. 2009, an airburst over Indonesia. Atmospheric airbursts of multi-kiloton energy occur on Earth, on average, once every 10 years. Tunguska-scale events are estimated, based on lunar cratering data, to occur approximately once per century. On the morning of June 30, 1908, the object detonated above one of the most uninhabited regions on Earth. Almost any other location would have produced casualties in the hundreds of thousands. The pattern is not the absence of cause. The pattern is the absence of warning. 117 years since the morning the sky split above stony Tunguska. 3 scientific hypotheses remain on file. None has produced the object. None has been refuted. The blast zone is regrown, the witnesses are dead, the trading post at Vanavara is now a small museum. The barometric records from Washington and the photographs from London survive in archives. The radial pattern of fallen trees, mapped by Kulik in 1927, is still visible from satellite. We do not file an answer. We record that on the morning of June 30, 1908, an unidentified celestial body released the energy of 1,000 Hiroshima bombs above the most isolated region on Earth, and that the scientific community has not, in the century since, produced consensus on what struck. Status, historical. File status, closed without resolution. And the next one is coming, cross-reference. 3 independent scientific frameworks have studied the event for over a century. None has produced a definitive object. The blast left a footprint and erased its cause. The file remains open. End of file.